For the synthesis filters, we have the baseband prototype filter G of n, which produces the subband filters given by G of k of n, with k is our subbands. How do we now design the prototype filters H of n and G of n such that we obtain perfect reconstruction? At this point, it is not even clear if it works with this modulation constraint we just introduced. To see that, we first construct the polyphase matrices. Here is the analysis polyphase matrix, and we get its elements given by these equations here. Observe the upper limit of our summation index is L divided by capital N minus 1, and here it's equal to 1 because we have L equals to 2n. So we have two blocks, block 0 and block 1. This means we only have two summands for m equals to 0 and m equals to 1. For the synthesis polyphase matrix, we get these equations here. And in this way, we obtain the analysis polyphase matrix given here. So here we have the page of MDCT, and we have all these elements of our analysis polyphase matrices. And here we see that we have our only polynomials of the first order as elements of our matrix. We have z to the power of 0, and we have z to the power of minus 1. The synthesis polyphase matrix is something similar, and we have here this synthesis polyphase matrix. So observe the corresponding time phase indices for the analysis and synthesis polyphase matrix, which run the transpose way for the synthesis. Here we have 0 and n, which is here, 0 and n. Here we have n minus 1, 2n minus 1 n, and we have n minus 1, 2n minus 1 n, and so on and so forth. The problem is that we still don't know how to proceed with the design of our prototype filters. We basically could start constructing an analysis polyphase matrix and then invert it to obtain perfect reconstruction. But the inverse of a polynomial matrix is not easy to compute, and also the inverse polyphase matrix might have filters which are not good. For instance, no real passband or not sufficient stop band attenuation, or we could get IIR filters instead of FIR filters. But here we can apply a trick that will help. Since we have a modulated filter bank, we have certain periodicities hidden in the impulse response and hence in the polyphase matrix. It is possible to investigate those periodicities manually and come up with a solution for perfect reconstruction. As Princeton and Bradley did in the late 80s, who first described the MDCT, which they called the TDAC then, it was the time domain aliasing cancellation, because that was the approach that they used. They analyzed all the aliasing components in the time domain and found one condition to cancel them in the time domain. And this leads to the sign window. And later, people, especially in the MPEG context, called it the MDCT.